Hi guys, here's a little intro on how to start today's lesson for your asynchronous work. If you look at the weekly assignments, it says complete the Phet simulation states of matter in your notebook. Mrs. Harris will help you get started. So here's the video of me, and you're going to use this website called Phet Sim Site. So you can go ahead and click that. And while that site is opening, you'll see Phet's interactive simulations come up. Looks like mine's going a little bit slow. And while I'm waiting for that one to come up, I want you to show you that you should have this open from your notebook. And it says, before you open the simulation, make a prediction. Draw a diagram below showing what you think the molecules will look like for each state of matter, solid, liquid, and gas. And write a sentence below each diagram predicting what the motion of the molecules will be like. Well, we kind of have an advantage here because we've been talking about this in class a little bit. But we're going to make a little model of solid particles, and we want to show them all locked together. So go ahead and draw some neatly arranged particles. And if we have to write a little description here, the molecules in a solid move like vibrating, and they move slow. If we heat those particles up, we get liquids. And these liquid particles all kind of slosh around. They'll move to the bottom of the container or wherever they're at. They definitely don't hold their shape. Draw a bunch of them fall down on the ground. And these particles, the molecules in a liquid, move like medium speed. And they slide. And for the gas, these particles, if they're heated up even more, they start bouncing all over the place. I'm going to put little action lines here to show that we have some particles zipping around here. And these are moving super fast and bouncing. So here we actually get to the simulation. So Phet simulation states of matter. Follow the link from Google Classroom. So that's the one that's on the weekly outline that I just showed you to access the simulation. Here's a logo. We're going to follow along on here with the actual interactive. The first question says, use the menu on the right side of the program to select water and solid. So let me go ahead and show you if it opened. Okay, so here's mine's ready to go. And I might click my other one. Nope, this one isn't really opening. Okay, so click the states of matter. And over on the right side, you'll see some options. So we have neon right now in blue. If we switch it to
the office, Mr. Antrim to the office.
Mr. Antrim needs to go to the office. If we switch it to argon, it changes kind of like a peaches color. Oxygen, you'll see the double oxygen molecule kind of looks a little red, and water. So we're going to make it on water, and we are going to click solid. So we want this to be solid water, and we're just going to draw a picture of what it looks like the best we can. So these are little water molecules, and they look like they're all kind of like locked together. So on your paper, go ahead and make a drawing of the water molecules. It doesn't have to be perfect, but we'll get an idea. And you can tell by looking at them, when you look at the simulation, you can tell that they are vibrating. They kind of look like they're like shaking in place. So in this simulation, you're going to experience or experiment with the temperatures and how the temperatures change the action of the molecules and also changing the type. So let's go back over to this and open up your paper to the inside. It says now use the slider on the bottom to add heat. So here's the slider right here. You can add heat, and you'll notice the temperature on the top is increasing. It's in Kelvin right now, so if you want to actually make more sense of it, if you switch it to Celsius, it'll be easier for us to kind of relate to it. So you can heat it up, and then you can like stop it, heat it, whatever you want to do to heat it up. So I have it in Celsius. And question number 3 says, what happens to the water particles as you increase the temperature? So as I keep making it hotter, what happens to the particles? These particles look like they're starting to break free on mine. Just now starting to break free. Holding it, and mine are starting to bounce everywhere. My temperature up there in Celsius is now at 300 and something degrees Celsius. I'm going to stop it right there, let those particles bounce around for a minute, and let's make a note in our paper. What happens to the water molecules as you increase the temperature? They start bouncing around. And they start moving faster. What is the melting and freezing point of water in Celsius? I'm going to show you how to do a couple more things on here, and then we'll see if you guys can work on this. What is the melting and freezing point? So if we start cooling this down, let's see if we can figure out when do those particles change back to a liquid. This might take a minute. Oh, there we go. I put the super coolers on, blasting some cold air on them. And the particles are slowing down. They're condensing together. My temperature is at 60s, and now it's in the 40s, 30s. And some of you might know the temperature in which the particles freeze. See if we can get it exact. I don't know if we can. 4, 3, 2, 1, 0. So I can't get mine 0. It's not letting me get exactly 0. But the melting point of water is 0 degrees. And the freezing point is also 0 degrees. So if you change it to a paper here, it says add heat until the temperature is just below and then just above the melting point of water. How is water different below its melting point and above it? So if the temperature is below the melting point, it's the point in which it melts. If the temperature is lower than that, it's actually a solid. If the temperature is above the melting point, it is a liquid. So you're going to use the menu on the right side of the program to select water and liquid, and then you're going to draw and describe what you see below. So you're going to go back over and you're going to change it to liquid. And you can see the temperature up here is at 13 degrees Celsius. And answer the questions on here. When you get over to number 12, it starts talking about changing it to a gas. And this is still with water. When you get to 13, you're going to switch to try neon, argon, and oxygen. This simulation, you're going to have both class periods on your at-home day this week to work on it. So you can split it in half, do half of it today and half of it on your next at-home day. And then by the end of the week, you should have it all the way complete. All right, hope that helps. Have a great day.